Okay, so we're going to cover Chapter 2, Section 5. Today we're going to prove statements about segments and angles. Now, I know last night if you go and you check your answers when you were solving those algebraic equations and the instructions said to justify each step, when you went to go check your answers, it wasn't written in two-column form, okay? Because now we're officially learning the different formats, but I wanted you to practice that skill. So instead of writing the statement and then writing a sentence afterwards, last night I expected you to write your homework as a two-column proof. So a two-column proof is the format we're going to use in this class throughout the year. A proof is a logical argument that shows a statement is true. Now, there's other formats to write a proof. There's the flowchart format, and then there's the paragraph proof. The only ones we're going to write in this class are going to be the two-column format. Now, for those of you who are looking for ways to practice writing a proof, you can even go to the homework, and any of the homework questions that say write a paragraph proof, you could still format it in a two-column proof. You would just read through the paragraph to make sure you cover everything that they've written in the paragraph is in your two columns. So the more practice you do with these proofs, the easier it's going to be for you. So in the statement column, what we're going to write here is either the given information or the result of applying a known property or a fact. We can also apply our postulates and our theorems as the statements. And then the reasons are going to be the explanation of why we wrote that statement. And on the next slide, we have the acceptable reasons for a proof. So an acceptable reason could be, first of all, always put that given right there at the beginning. They can also be definitions. It can be properties, which we have been seeing when we were doing our algebra proofs. It can be properties, postulates, and theorems. Now, what it means here by previously proven ones, we can only use information that I have taught you about. So you cannot use information from Chapter 10 until we get to Chapter 10. So right now, the only thing you can use when you're writing your proofs for your homework tonight is any information in Chapter 1 or in Chapter 2. Can't use anything later on in the book yet. Remember, geometry is going to be cumulative. So what that means is whatever you're going to learn in Chapter 1 could be fair game on a test in Chapter 10. So even when we get to May and June and we're ready to take that final, your final exam could have vertical angles, which we learned in Chapter 1. So everything we're learning could appear on any test throughout the school year. Okay, and we're going to see that quite often when we're writing our proofs. So a theorem is a statement that can be proven. And the way that we're going to prove these theorems is using deductive reasoning. So we have to use facts. We're going to be using definitions, postulates, whatever knowledge we have. That's what we're going to use to prove a theorem. Now, the next two theorems that are listed here, again, do not memorize the numbers. You just need to memorize the name or what it says. And this is what we learned yesterday, that the properties of segment congruence, the reflexive, the symmetric, and transitive, these are now applied to segments, but now instead of an equal sign, it's going to have a congruent symbol. And if you recall, the congruent symbol is the equal sign with the wave on top. So exactly the same thing we saw yesterday, now we're just going to change the equal sign to a congruence. And again, for my class, you can interchangeably use the congruent symbol and the equal sign. You don't have to specify that it's the transitive property of congruence versus the transitive property of equality. You can just put the word transitive in there. You don't have to specify. So same thing for the angles. You can use the reflexive, symmetric, and transitive. The next slide has that same chart that we saw yesterday, but now what they've done, we've changed the symbol in between from an equal sign now to a congruent symbol. So all they're saying here is that segment DE is equal to segment D, is congruent to segment DE, and this is your reflexive property. Same thing for the symmetric. It's like a line of symmetry, or you can also think of it as being an order that's switched up. So yesterday, this word was equality. Today, it's congruence. So same properties. The only thing they're changing is now, instead of an equal sign, it's a congruent symbol. Yes?
So basically, it's just, when it's a property now, you just do the congruent sign, not equal.
It's still a property. So it was a property of equality before. The only difference, yesterday, they had DE equals DE. And the difference between the equal sign and the congruent symbol, generally when you see the equal sign, we're concerned about exactly how much it measures. So let's say DE was 5, then you could say 5 equals 5. But when it's the congruency symbol, all I care about is I know that DE is the same size as DE, and I don't care how big it is.
Yeah.
Does that make sense? So you can use them interchangeably. I don't care that you have to specify. Like before, yesterday I was telling you that you could add in POE, property of equality. If you want to add in POC for property of congruence, you can, but I don't need to see that.
Okay.
Make sense?
Thank you.
You're welcome. All right, let's see what's next. So we're going to write a 2-column proof here, a geometry proof. Now, this could be like the scenario that you would get on the test next week, where I fill in all the statements and you only have to come up with the reasons. So this is how I'll slowly introduce the proofs to you on your tests and quizzes. So the first step is always, in my case, I always list it as the given, and that's what was given to us. Notice this time the given was written out here in letters. It wasn't marked on the picture. So here our given was AC is equal to AB plus AB. They want me to try to prove that AB is congruent to BC. That's what they want me to show. So they've already listed all the statements. I just have to figure out what definition or what postulate or what property I can use to justify what they wrote, what they did.
So we're not solving it.
No, you're just proving it, and you're giving the reasons why they did what they did. Good? Okay, so my next statement is actually my segment addition postulate. They're showing that segment AB plus segment BC creates or makes up the whole thing of AC. So this reason is going to be your segment addition postulate. And this is called, I abbreviate it as SAP. If you don't want to abbreviate it, then you write out all 3 words. The next one, what they've done here is, if you notice up above, they told us that AC was equal to AB plus AB in the first step. So I'm going to take out AC, and I'm going to put what AC equals, which is AB plus AB, and that's what they put here. So instead of writing AC here, they put AB plus AB, and they set it equal to what was there. So this is substitution. So we substituted AC, we took out AC and put what AC equals, which is AB plus AB. And then lastly, those properties of algebra that we just did last night, the addition, subtraction, multiplication, division, can also be applied to segments and angles. Right now we're going to apply it to a segment. And what they did from step 3 to step 4 was they subtracted AB from both sides. And that's how they got AB equals BC. So this is the subtraction property of equality. And you're done. So the goal here is to somehow introduce these letters into your proof. And the way that I could get BC in here, I already had AB in it because it was given to me, is I could introduce and show how the segment addition postulate applies to this problem. And the segment addition postulate tells me I can add the two little pieces to make one big piece. And that's how I got from step 1 to 2. I didn't change anything in step 1. I just added in the postulate.
Oh, I wasn't looking at the segment.
Okay, does that make sense? So sometimes you have to look at the picture as well as the given. Does that make sense? So just look at everything that's given to you to help you determine how to get there. Yes?
So...
All right, so let's try another one. This one is bringing in our knowledge of a midpoint. So here it's telling me that M is the midpoint of AB. You should know by definition of a midpoint that it splits the segment into two congruent pieces. So this tells me that AM is going to be congruent or equal to MB. And that's what I need to put into my proof. And that's the second statement. So the first one is given. The second one is applying that given information, and I'm using the definition of midpoint. That's how I know that AM is congruent to MB. Now, from step 2 to 3, what they've done is change that congruent sign to an equal sign. I'm okay with you skipping that step, but what the step is really doing is just showing you that you can change it from a congruence to an equal sign, and that reason is the definition, I'm going to abbreviate definition to DEF, of congruent segments. So congruent segments are also equal segments. So all they did was change it from a congruence to an equal sign. If you want to just work with it as a congruent symbol throughout the problem or an equal sign, you don't need to switch it up and put that statement in there if you don't want to. However, if it's a proof that has been given you the statements, you need to justify that with this definition reason. Okay, the next one. We somehow need to get in some more things in here. So I'm going to also establish my segment addition postulate by showing how AB is created. And AB is made up of adding AM plus MB, and it equals the whole thing. And that's my segment addition postulate. And that's what they did in step 4. Now, I can abbreviate it, or you can write out segment addition postulate. I'm just going to put in SAP. That's my abbreviation for segment addition postulate. Now, to go from 4 to 5, what they've done is notice what changed was this MB, and it now became an AM. So if you notice the step above, MB equals AM. So what they did was they took out MB and they substituted it for what it equals, which was AM. So from step 4 to 5, the reason for 5 is substitution. And now from step 5 to step 6, all they did was add like terms. They added this 1 a.m. plus 1 a.m., and that's how they got the 2 a.m. So this is not addition, because remember, the addition property is when you add something to both sides. Here, all they did was simplify. So they combined like terms. And then lastly, from step 6A, or from 6 to 7, what they did was you can either say division, or if you want to think of it as multiply by the reciprocal, I would accept either answer there. Because what they did was divide both sides by 2, and that's how they got the AM equals 1/2 AB. So you could either say division here, or I would also accept multiplication, because when you divide fractions, you multiply by the reciprocal. And these would be property of equality, but again, you don't need to add that if you don't want to. Yes. So here is just a general overview for writing a 2-column proof. So when you're writing the 2-column proof, you're just going to go one statement at a time. You've got to provide a reason for each statement you're putting in there. Now, sometimes you're going to flow from the statement up above to the next one. Other times you're going to be bringing in information about what you see maybe in the diagram. And it has to be based on deductive reasoning. So you have to use facts when you're making these statements. And then just don't throw random things in there just to fill these columns. It has to flow logically. Some people like to put the given when they need it. I like to always put it at the beginning so I don't forget about it. You may not need to use the given right away. You might not need it till step 3, but you don't need to restate it again. So when you're writing your statements, as long as you've got something in there, you can use it to give your next statement. And it doesn't have to be right under it. And again, this will make more sense as we go through it. Now, for this proof that's here, they started out by giving us that angle 1 was congruent to angle 2. But they wanted us to show the reverse, that angle 2 was congruent to angle 1. Now, they went ahead and they went through the process of changing up the congruent to an equal sign. I'm okay, again, with you just going from eliminating this and just going straight down to here and just show that they switched up the order, and you could have just said symmetric on this one. All right, so I don't need to see how you have to switch it from congruent to equal and then back again. But again, if this were a test question and I had given you the statements, understand that you would have to justify each statement with a reason. So again, your reasons need to be definitions, postulates, theorems, things like that. And again, you can only use things that I've taught you. Can't pull stuff from chapter 8 or 9 or 10 until we get there. Now, tonight's homework, I do realize your first exposure to proofs are going to be a bit challenging. Attempt it. Do not put a bunch of question marks on your homework. I want you to give an honest attempt. Now, the homework questions I gave you were odds. So you can even look at the answers. And that's what I want you to do if you don't know where to even begin. Again, it's going to take a little bit of practice. So what I want to show you now are the 4 apps that you can find for your textbook from the App Store. And then I also want to show you the skills trainer that is in your textbook. All right, so I'm going to show you those things. And then whatever time's left, you can start on your homework. I didn't give you too many homework problems, but at least give it your best shot tonight.